Hello, everyone. We're here to discuss a crucial shift in the landscape of clean energy, specifically concerning green ammonia. For a long time, the conversation around ammonia's role in a decarbonized future has naturally centered on agriculture, its traditional and massive end use. And for good reason, ammonia is foundational to global food production. However, a significant development is underway. The maritime sector, with its immense logistical demands and unique operational pressures, is now forcing green ammonia to prove its commercial viability and operational reliability. This is happening under an extreme level of economic and practical scrutiny, much earlier and more intensely than the agricultural sector ever could. Shipping isn't just asking for green ammonia, it's demanding it and putting it to the ultimate real-world test. This critical proving ground will shape the future of green ammonia far beyond just fertilizer. Let's consider the historical context. Ammonia has always been a vital component of the agriculture story, feeding the world and sustaining global populations. Its potential as a storable form of hydrogen has long been recognized within this context. Yet fertilizer buyers, operating in a highly cost-sensitive commodity market, have made it challenging for green premiums to gain widespread commercial traction. Decarbonizing agriculture is essential, but the market signals for a rapid transition to green ammonia have been somewhat diffuse. Now shift your focus to shipping. This industry is emerging as a critical driver for green ammonia, not out of altruism, but out of absolute necessity. Heavy cargo, long distances across oceans, and the inherent limitations of batteries mean that dense fuels are non-negotiable. Direct hydrogen, while theoretically clean, presents significant storage and handling difficulties on board ships. This is where ammonia steps in, offering a far more practical alternative. Couple this with increasing regulatory mandates and capital market pressure to decarbonize, and you have a sector that is actively seeking and funding these new fuel solutions. What we're witnessing today is a profound shift from vague interest and aspirational targets to concrete commercial commitments. This isn't just about discussions at conferences or policy memos outlining future possibilities. We're seeing real procurement structures being put in place directly linked to actual cargo movement and daily shipping operations. Take, for example, Hapag-Lloyd's commitment to 70,000 tons of e-methanol from 2027, or North Sea Container Line's agreement for 25,000 tons of e-ammonia, also starting in 2027, with Yara Clean Ammonia as a key supplier. These are not speculative investments. They are binding deals. They signify that the green molecule is no longer confined to the lab or limited to policy discussions. It is now entering a buyer-mediated commercial pathway driven by the operational needs of the shipping industry. This signals a turning point where commercial reality is setting the timetable for clean fuels. Shipping truly represents a harder and perhaps more honest test for green ammonia due to its complex system analysis. First, there's the energy density problem. Ocean shipping demands incredibly dense fuels for heavy, long-haul cargo. Batteries simply aren't viable for deep-sea applications, making ammonia a much more promising long-haul molecule. Second, consider the existing handling familiarity. While using ammonia as a fuel adds new challenges related to bunkering, safety, and engine design, the world isn't starting from scratch. Ammonia is already shipped globally as an industrial chemical, meaning there's a foundation of experience. Third, the regulatory vector is powerful. International bodies like the IMO with its net zero framework and regional policies like EU Fuel EU Maritime are creating undeniable investment signals. While policy implementation always has friction, the direction is clear and reinforcing. Finally, there's visible accountability. In shipping, delays are incredibly expensive, and operational failures are immediately visible. Fuel must be delivered on time and certified to keep cargo moving. This acts as a harsh, real-world filter in nascent clean fuel markets, ensuring only the most robust solutions prevail. To truly understand why shipping is such a critical proving ground, we need to compare the fundamental problem structures between agriculture and shipping. In agriculture, there's high end-use familiarity. Ammonia is already the product, well understood and deeply integrated. However, the decarbonization driver for agriculture is often diffuse, with premium absorption being difficult to pull through a commodity value chain. The market signal is broad and often slow, and ammonia's strategic role is primarily as a commodity input. Shipping, on the other hand, presents a different scenario. There's low end-use familiarity for ammonia as a fuel, it must prove itself in this new application. The decarbonization driver is intense and immediate, fueled by strict regulations and reputational pressure. Premium absorption is becoming feasible through cargo owner willingness and regulatory frameworks. The market signal is concentrated and urgent, with ship owners actively committing capital. Ammonia's strategic role here is transformative. It's an energy carrier enabling a new energy system, not just a chemical input. This difference in fundamental structure is why shipping will define ammonia's future. The shipping industry is not just talking about decarbonization, it's putting serious capital behind it. We're seeing unprecedented investment driven by the need for future fuel certainty. By the end of 2025, over $150 billion will have been committed to dual-fuel ships. This isn't a small experimental budget. It's a monumental investment in new vessel technology. Consider this. An astonishing 74% of all new container ship and vehicle carrier orders are designed with dual-fuel capabilities. This clearly demonstrates a strong, forward-looking commitment from ship owners to be ready for lower carbon fuels. Beyond vessel orders, there are over 50 pilot and demonstration projects underway, exploring ammonia, hydrogen, and battery propulsion. What does this all mean for green ammonia? It signifies that ship owners are making substantial long-term hardware commitments for lower carbon fuels. This, in turn, creates a powerful demand signal and exerts immense pressure on fuel developers to deliver practical, scalable, and reliable solutions. The capital is flowing, and the industry is actively driving the market for these new energy carriers. The real question then is whether green ammonia can truly survive the rigorous stress test presented by the shipping industry. There are several critical aspects that remain either unresolved or are still very much in progress. Production at scale is a major hurdle. Can we produce green ammonia cost competitively and in sufficient volumes to meet global shipping demand? This is largely unresolved. Similarly, bunkering infrastructure, the network for fueling ships with ammonia at ports worldwide, is also currently unresolved. However, progress is being made in other areas. Engine and onboard readiness for diverse vessel classes, including fuel systems and safety protocols, is actively in progress. The same goes for crew and insurer comfort, addressing toxicity handling and overall risk management. Emission certification, verifying the well-to-wake emissions profiles of green ammonia, is also an ongoing effort. Finally, premium tolerance is still largely unresolved. Will cargo owners and ultimately consumers be willing and able to absorb the necessary premium to scale these crucial supply chains? All these systemic challenges must be overcome for green ammonia to become a viable and widespread shipping fuel. When we consider the technological stress test of maritime transport, ammonia clearly emerges with a strategic advantage over direct hydrogen. Direct hydrogen presents significant challenges. It has severe volume penalties, even at very high pressures, and requires cryogenic storage at an extremely low 253 degrees Celsius, which is complex and costly for a vessel. It's incredibly difficult to bunker at scale across global ports, and boil-off losses during long ocean transits would be substantial. Furthermore, onboard storage would add significant weight to the vessel, reducing cargo capacity. Ammonia, however, offers a far more practical systems compromise. It becomes liquid at a much more manageable 33 degrees Celsius, making it considerably easier to handle than cryogenic hydrogen. There's also an existing global shipping infrastructure for ammonia as an industrial chemical, which provides a valuable head start. Ammonia boasts a higher volumetric energy density than hydrogen and benefits from established safety protocols, though its use as a fuel does introduce new challenges. Crucially, it carries hydrogen in a storable form, which can then be cracked if direct hydrogen is eventually needed for certain applications. As a fundamental principle, markets often scale practical compromises long before they scale elegant, theoretical solutions. The demand from shipping for clean ammonia is rapidly accelerating a global divide, particularly in terms of geopolitics and trade. We're seeing the emergence of export-oriented ammonia hubs. Regions blessed with the lowest cost renewables, such as Chile, Australia, the Middle East, and North Africa, are becoming disproportionately important players in global shipping corridors. This leads to the concept of corridor control. As fuel begins to cross international borders specifically for marine use, strategic trade position, robust certification standards, and reliable supply chains will become critical competitive advantages. This inevitably creates a countries that build gap. Shipping accelerates the divergence between nations that merely talk about hydrogen and those that are actively building integrated clean fuel systems with real port infrastructure and export capabilities. Ultimately, this changes the new infrastructure investment logic. Location decisions are no longer solely about local demand. Port adjacency, stringent fuel certification requirements, and project designs directly linked to established shipping corridors are now critically important, differentiating clean ammonia projects for shipping from traditional domestic fertilizer plants. It's crucial to understand that green ammonia is not a monolithic market. Rather, it encompasses several distinct pathways and applications, each with its own characteristics and drivers. We have green ammonia for fertilizer, which leverages its legacy scale and existing demand. Then there's green ammonia for shipping, the focus of our discussion today, driven by fuel decarbonization needs. Ammonia also functions as a highly effective H2 carrier, enabling the transport of hydrogen across vast distances. It can be used for ammonia for power generation, providing a carbon-free fuel source. There's also a significant role for ammonia for export corridors, which involves developing global trade routes for this new energy commodity. Finally, ammonia for industrial decarbonization represents its use in various hard-to-abate industrial processes. Each of these pathways has a unique market structure, value proposition, and set of challenges that developers must navigate. To summarize our journey today, it's fair to say that agriculture has historically explained ammonia. It provided the foundational demand base, establishing ammonia's importance at a civilization scale and its legacy role in global food systems. While vital for decarbonizing fertilizer production, agriculture has found it challenging to pull a significant green premium through its commodity value chain. However, shipping is now testing it. This sector is the first to truly force commercial validation of green ammonia under immense operational pressure. It's subject to intense regulatory and capital market scrutiny, creating a clear premium pathway that mandates infrastructure development and robust certification. If green ammonia can survive the rigorous real-world filter of the shipping industry, proving its scalability, reliability, and economic viability, it will stop being merely a decarbonized version of an old chemical. Instead, it will be validated as a fundamental component of a new global energy system, unlocking its full potential across multiple sectors. For those of you navigating this complex and rapidly evolving hydrogen economy, we built H2 Hub by Renee Energy, specifically for the professionals who are determined to win. These are the individuals and teams who understand that success hinges on mastering conversion under system stress.